Hello everyone, my name is Zarima Muhammad Al Abdouli and today we will talk about our project. It's called Ecaqua Bot because it is eco-friendly and it's related to water. A smart following line robot that follows a black line and it's sustainable for our agriculture. With Arima Muhammad, Reem Adil, Meetha Al-Dhahri and Noura Salim from Grade 10 Advance.
And here's the video that we made it by AI.
Why did we choose this project? So first, we found out in the UAE there's a lot of water waste in our agriculture. So the water and the plants are overwatering. This causes the damage of the soil. So the manual checking is so slow and inefficient, and the people need to know that water security is a very serious problem.
Environmental and national impacts are that it saves water, reduce chemical filtration, and recycle fish water tank. And it also supports sustainable agriculture and protects soil chemistry.
So our solution is to use Lego Educational Spike Prime to build this robot. So first, we built it by Lego Educational Spike. Second, we added color sensors so the black line, like the car moves at a black line. Third, we added the ultrasonic sensors so it measures the distance, and we also added the soil moisture sensor so they can measure the soil if it's dry or wet, and we also added the angular sensor to move more smoothly.
How the system works. Robot follows the black line automatically and stops at each plant position. Robot's arm moves into the soil and waits 5 seconds to read the soil moisture. Green light means the soil is wet, so no water needed. But red line means the soil is dry, so the robot must water the plant. Water pump turns on until the soil becomes wet. Finally, the robot moves to the next plant.
As we learned in our chemistry class that this is the pH scale, and the range from 0 to 6 is acidic, and the range from 8 to 14 is alkaline, and 7 is neutral. And the most of the plant go best at the pH of 6 to 7.5. And how does chemistry help us decide when to water? It's depend on the moisture level. Like example, if it's from 0 to 30%, the moisture level is dry. It means we need to pour some water in the plant. But if it's from 30 to 70%, the moisture level is normal, so we don't need to do anything to the plant. But if it's from 70 to 100%, the moisture level is high. It means the plant has too many water in it, so we don't need to pour any water. If you scan the QR code, it will show you this data that explains that every percent its soil state and the decision that we must make. An example, like 25% the soil state is dry, so we need to pour some water to the plant. If it's 45%, the soil state is moist, so we need to wait until the plant needs some water. And at 65, its soil state is healthy, so we need to wait until we pour some water to the plant. But if it's 75%, it means that the plant is too wet. There's too many water in the plant, so we need to not pour any water in the plant.
Healthy soil contains water, H2O, minerals, NPK, organic matter, and microorganisms. Using fish tank water, fish waste produce ammonia, NH3, and bacteria convert ammonia into nitrate, which is NO3-. Nitrate dissolve in water and are easily absorbed by plants. This reduces the need for chemical fertilizer.
This is our project chatbot. If you scan this QR code, it will show you this page that shows the questions answered, about 8 to 10 questions.
Our future goal, we need to have accurate details. and solar energy, and the most important thing, which is AI to predict, so it can be healthier in our future. And here the QR code that you can scan and play.
Thank you for listening.